Right, so for user authentication, some basics. The two most common ways people authenticate nowadays are they'll typically always use tokens, and sometimes it is also auth0 or auth0 or OAuth, however you want to state that. We are not going to do auth0 or OAuth. We're going to use tokens, which, to be fair, authentication uses tokens as well. It just uses a couple more. We're just going to use one. And a token is like your entry ticket, right? So you buy your ticket to a park of some sort, you scan it at the gate, you're let in. And how it used to be at parks, you know, you'd still have to scan tickets at every ride. Obviously that's changed. But in this instance, the way that token authentication works is the user, in order to get to anything that requires authentication, they're gonna have to log in or sign up. And when they do that, our server has to authenticate them, generate a token, and send that back to them. So that on the front end, anytime they're making a Axios request that requires authentication, they can send us that token back. They send it back to the server. The server can check, be like, yes, this passed, this is valid. Let them through, let them get the data they're requesting because they have been authenticated. So that is the purpose of a token. It's going to take a second to lead up to that, and we're going to be adding a couple more node modules as well to achieve this effect. So what I have here is a server.js with my package JSON. I've installed Express, Mongoose, and Morgan, the ones that we've covered. And that's it, empty server file here. So we'll start by setting up server as we have before. Express, const app equals require, or express being called. We've been creating port variables. And then we need to require our other dependencies, so Morgan and Mongoose. We add our middlewares for every request, which is telling our server to use express.json for the user sending us post to put requests, and the Morgan as our console logger. We still set up our database connection the same way. All this is review, so please stop me if you have any questions on these that you've run into while working with it. We give it our configuration object with use new URL parser true, use find and modify true, and use create index false. It then comes back or it doesn't. Next on the line, we have our routes, which we'll fill in shortly. What do we have right after our routes? Global error handler, cool. And what are the 4 arguments we need to pass into app.use so that it knows it's for error handling? Error, rec.res, and next, yes. And we'll console.error the error if one occurs, and then we'll return our error with a specific key so they all look the same on the front end. And then we have our server listen. All right, so it's kind of quick, but there is our standard boilerplate for the way that we're building our servers. Get this full page. All right, so when we are building our servers, What do we build first, models or routes? Models. Can anyone give me a reason why? Yeah, how do we know what we're interacting with before we've defined what we're interacting with? So we're defining our data, what it looks like, and then we'll define how do we interact with that data. So you're not having to pop back and forth, back and forth. So first we'll define our model. And what this app is gonna be is a to-do application with user authentication. So the user logs in, they can see maybe everybody's to-dos, but they can also go to their own page and get just their own to-dos. So how many models will that be? 2. We have our user model and we have our to-do model. What is the relationship between these if we're talking database relationships? One to many. Which one's the one? The user. So what gets the ID of the other? The to-do will get the ID of the user it belongs to. So let's start off by defining what our user model looks like. Now you can expand onto this for your own reasons. We're just going to give it 3 keys. We will create our user schema as a new Mongoose schema. And we will module.exports a Mongoose model named user referencing the user schema. All right, so for user authentication, we're going to give 3 keys here. We're going to give it a username, and it's going to be a string, but we want to make sure there can be no duplicates and that it's required. So what 3 keys would I need to add to this username property to affect that? Unique, true, required, true. Then how could we enforce that it's unique? Let's say my username was Jack and someone else's username was Jack, but I did it with a capital J, you did it with lowercase j, so that's not unique. Yeah, if I lowercase it, it'll make sure everyone's username is saved in the same casing, making it so duplicates can't occur, right? No one can have the same username. You could swap username for password. That's even easier because most, emails are not. I said username, yeah, for an email because that will also not be duplicated, typically. Password will be another key. It will just be a type string, and it's also required. Lastly, if you're thinking of a website like a CMS, does anyone know what a CMS is? A content management system. So think, I have a client that writes blogs and they need a blog site. So there is a side of that website only the visitors see. That is the finalized blogs. And then there's a side of the site that only the blog writer sees, where they can go in, write a new blog, hit, submit, and it shows up. So if you're wanting this functionality, you could add something like an isAdmin property to each user, which would be a Boolean. And by default, everyone has it as false. But then the person that you are allowing to have admin privileges on this site, all you need to do is set this to true, and we could code into our React app other routes that only someone as an admin can access, which would be the CMS side of it, where they can actually go and add content to the site. So you can definitely add more than this to your user schema, but this is the base requirements we'd want for authentication. Any questions on the user schema? Ooh, okay. In that case, we can go and define our to-do schema. So I'm just going to take this and move it over. So we can take our to-do schema and make it as well. We'll module.exports a model as well called to-do, referencing the to-do schema. And we're going to keep this pretty straightforward. We're just going to do a title for now. So it's definitely required. But what other key must this schema have? User. Why user? Why do we need to have a .user on our to-do objects? Yeah, it needs to know who does it belong to, so that we can say todos.find and find all todos whose .user matches the ID of the user requesting it. We can get this sub collection out of all of our todos. The type for this, how do we reference the ID of another object in our database? Schema.types. And then we could say any of these, but we're looking for object ID. It looks like a string, but if you said string here instead of type, schema types object ID, it won't work. It won't relate itself in the database. Not only do we need to tell it it's an ID, but we need to reference the model that ID belongs to, which would be the name that we gave the model on the other file, so uppercase user. And then we want to make sure every to-do knows who it belongs to, so we're going to make sure nothing can be saved unless we have the user ID attached. And that's all we're going to do with our to-do schema right now. Keep it very straightforward. So we have our to-dos that have a title and a user, and we have a user that has a username, password, and is admin. Good so far? Two models, none of this should really look new. I think we covered this briefly with the authors and books. But now we've set up a relationship. We won't look in Mongo Compass and see them relating. It's all about when we query our to-dos, being able to find some with the same user property. Right, next are routes. We're going to start off with the user router. And in fact, I'm not going to call this user router. I'm going to call it auth router. Because these are just the routes for authentication purposes. I could still make a user router file for other user type interactions, but I'm going to separate this into its own little file so I can see this is the file for login, sign up, those types of HTTP requests. So we'll pull an express again. We'll make our auth router. And we'll pull in our user model. Before we forget, we'll module.export. All right, so what this file is going to be for is sign up and login. That is what this file's purpose is. When the user hits our main page and wants to log in, these are the routes that are going to be triggered. And what these routes need to do is they need to authenticate the user, and they also need to create and send a token. If these work successfully, we need to create the token and send it to the front end so they can then be logged in and access the other parts of our site that require it. So we're going to start off with the sign up route. Auth router dot, what do we think for a sign up or login? Get, post, put, or delete? Post. Why? I heard post. Why post? Post is correct. It'll be to / sign up, but why wouldn't? Yeah, I'm going to be sending you my username and my password as the request body. So it's got to be a post request to do that. What the? Res and next. All right. So during this process, again, we need to authenticate and create a token, but we haven't installed anything yet to help us create a token. So we're going to pause here before filling in this route and get the ability to generate tokens and keep them secure. There's a couple pieces. So first, we need to install a package called JSON Web Token, one word. npm install JSON Web Token. And this package creates tokens. We can use it to create, generate, all those types of things. So I'm going to pull that into this file as well. JSON web token, and I'm saving it in a variable called JWT. This is a very conventional name for JSON web tokens. You'll hear them referred to as JOTs. And there's a method on this called sign that we use to create tokens. So JSON web tokens are their own little subjects, so we're going to look at them briefly here. So this is the jot.io website, the token. This is the package that we're using. And this is what a token looks like once it's generated. It is three seemingly randomly strings, three seemingly random strings separated by periods. The first section is the header. We don't need to worry about this. This just contains the algorithm and the type of what we're making. JSON web tokens have this built into it, how it encodes the token. The second segment is the payload. This is very important. This is going to have our user information in it so that we have access to the user information through the token automatically. And then the last section is the signature that is also encoded. And this is what validates the token. So tokens, you want to be very clear, they're not to make your information secure. This is, I can't say incredibly easy, but anyone with a little know-how could decrypt this and take all the information from it. So a token is not for passing secure information. What they're for is verifying that the requester is sending you a token that this server created. So if this server creates a token, it'll have to use a specific signature so it knows it's from this server. And when the user sends a request, if the token signature doesn't match the one that this server gave it, it'll reject it. It will say, you weren't authenticated through this server, so you don't have access. And that is the purpose of a token, making sure the request is being done by someone authenticated by that same server. And this is the piece that really counts for that. So again, it's not a secure way of passing data, but it is a secure way of validating whether or not the requester was verified by you, not by someone else, or that it's not malicious. Okay, that is JSON web tokens. And that's what we have here, the ability to create those now. But like I said, the signature is the most important part. How does the token know the request or the token was created on this server? Well, we're going to use an environment variable. So what is the name of the file I need to create for environment variables? .env. We've done this in React, right? Keeping variables private. How do we make sure this doesn't go to GitHub then? Add it to the git ignore. And that's how we're going to make sure that our server's secret information stays secret, so that when our tokens are encoded, no one has access to how it was encoded, because that's staying locally. Well, unfortunately, env files do not work just by making an env file. Create React App sets up the environment for that to work, but if you're introducing this to a Node application like this, where we don't have a framework being set up for us, we need to make sure this works. So there's one more Node module we install for that. We npm install a package called .env. So fairly easy to remember the name of the package. It's the name of the file, but you spell the whole word dot. .env is the name there. And all this package is used to do is to configure the ability to create this env file. So right up here, right after we create our server, all we're going to do is require .env.config. That's all we have to add, and now our env file will work just like it did with Create React App. So fairly simple setup, but now we have the ability to keep things secret. So .env is the name of the package, and we just require its configuration to make it work. Now we have the parts necessary for setting up tokens. Which means we can do our routes. So to the auth router. Actually, is there any questions on the .env or the JSON web tokens before we go forward? All conceptual right now, so it doesn't need to make complete sense, but you have an idea what they are, what they're going to be used for.
On the file list, why isn't .env grayed out?
Because I'm not in a repository right now. But if I were, yeah, this would be grayed out and this would be grayed out because they're both in here. Okay, now let's make our sign up route. Let's get the ability to create a user. Now, usually in a post request, we immediately take the request body, right? And we say, you know, new, we'd say something like new user equals a new user and pass in the request body. We can't do this with user authentication because what if this request body has a username that already exists? It fails. Yeah, it's just like, that already happened before, so you can't do this. So what we'd like to do first is check the database to see if the requested username already exists. If it does, send back an error. If it doesn't, create the user and the token, send them both back. So we need to do 2 queries to our database first. Or overall, we first need to check, do they exist? And only if they don't exist do we create the new user and save it. Well, how could I see if a user with the requested username already exists with the user.find? Use the filter object, and we're looking for username is equal to what? How is the user sending us their requested username for their sign up? rec.body.username, right? They will have sent that in a post request. Now, this is going to send back what kind of data type? Find will always return an array, even if there's only one object. We really want to be dealing with an object here because we're really only looking to see if this exists once. So we'll say find one whose username equals this, and then send back either an error or the user. Well, the first thing we need to do with any node server is first see, was there an error? And if so, handle it. And that doesn't change. There's our standard error handling. But then how could we see if the user has been taken? This requires us to know what does MongoDB send back. First of all, what does it send back if it finds the user object? Yeah, it sends us the user object. But what if it doesn't find a user? What does MongoDB send back? It sends a falsy value, typically null, which is nice because then we can ask this in an if statement. If that user exists, then, you know, we're in trouble. So you could ask this one of 2 ways. You could ask if user is not equal to null, right? That means if the user exists, then we need to send an error saying, hey, that username's taken. But we can also ask if there's not a user object, if it's null, that works the same way. So if there is not a user, or rather, sorry, if there is a user, that's bad. That means this username is taken, and we need to let the user know. So we'll set the status to a new status code. The 400s are for authentication errors, so that's what we'll be using here. 400, not 4,000. If the user exists, let them know that's not an authorized request. That doesn't match because that user is already taken. But then we need to send an error. But do we have an error object to send? No, this error is just like I couldn't find anything or the server broke. So now we've hit the first situation where we need to make our own custom error object that works the same way as this one. So what we'll pass to next is a new error, and whatever we put inside of the error constructor will be the error's message, just like this has an error message. So what would be a good error message to send if you tried to sign up with a username that's already taken? That username is already taken. Cool. And we can receive that on the front end and show it to the user on our signup page. But if they make it past this check, if the user does not exist, if this is a falsy value, then we're good to go. That means that username's not taken. Let's create our new user. So this is where we can do our const new user equals a new user with the request body. Then do our whole new user dot save, which will bring back an error or the saved user. So here's our first database query. Here's our second database query. The error handling is the exact same for node errors. So if there was an error, res.status 500, return next with the error. But if there was no error, that means at this point, the user was saved successfully. So we need to send back a token and the user object for our front end. First thing we'll do is create the token, and then we'll do our return res.send and send everything back, the saved user and the token. So this is how a token is created. We're using JSON Web Tokens. You'll create a variable called token, and on our package, JWT, we'll say jwt.sign. And this is the method that does need to take some arguments, but it will return the token that has the header, the payload, and the signature. So first argument is the payload. What do we want encoded as the payload? The most reasonable thing for this is the user itself. We want this user object encoded in our token. But when this comes back from the database, we haven't talked about this. What data type is this right now? Before we res.send it and Axios receives it, what format is this in? It's JSON, because that's how everything is saved in MongoDB. Technically, it's called BSON. It looks like JSON, but it's for MongoDB. But yeah, it's not an object yet. And the token JOT_SIGN needs a plain JavaScript object. Fortunately, MongoDB has a two-object method that you can call on BSON objects that turn them into JavaScript, just like JSON.parse. So we will first pass in our payload, the saved user, to object. Turn them into an object when we send them. The second argument is the token or the signature. How do we know that this token came from this server? Well, this is where the environment file becomes very important. We need to create something called a secret. So I'll go to my environment file and create an all caps secret equal to a string. And there's a lot of talks about encryption and what's best to be chosen as a secret. You know, do you use a random string of characters and numbers, all that? What they've said is random words work best. That's the hardest thing for a computer to guess. So we're just going to put 4 random words in here. We're going to say unicorn, violet, lunch, yes, and pinata. Cool. There is my secret, and that is staying on my computer. But this is what I'm going to be giving the jot.sign method so that it encodes it using this secret, and only by having this secret can you decode it. So in my auth router here, where it needs the secret, I will refer to it as process.env.secret. Now it has the payload to encode and the secret for the signature. And it will create the token and store it in this variable. The last step is just to send it all back. Return res.status 201, because we just made a new user in our database. And we'll .send an object that has the token and the user inside of it. So on the front end, when you do a sign-up request, the response.data that comes back will have a .token and a .user and have all the information. Now this is not super secure yet because what will be inside of this saved user object? Username, password. We're sending the password to our front end where anyone with DevTools can open it up and see it. So we will have to change this a little bit later, but we're going to stick to this format. And that is our sign-up route for now. It's a little bit more, right? It's probably a heftier route than what you've written, but let's test it and make sure it works. Even more so we can see what these tokens look like when they come back. I must have another server running, so we're going to do a... Is this one false and the other one's true? And not 7,000, 27017. Cool. Okay, so our server's running and we're going to test creating a user. But I don't have my route set up yet. So let's set up our authentication routes that uses the auth router. So we'll say app.use, any request to /auth will require the authentication router. So what is the endpoint for a sign-up request? /auth /signup. So we're going to do a post request to /auth /signup. We don't need any token or anything in here. The content type should always just be there by default. And then what does the body need to look like? And what else? Password. Now I'm choosing very simple characters because when you're testing user auth, you're going to be creating a lot of users. If you're like, cool, Nate123, password, Nate123. About the 50th time you're testing that, you're going to get really tired of typing in that username and password. For testing purposes, just choose letters and such. It's really easy to delete your database and start over. Let's see if this works though. We will post. There we go. Here's our response.data. It has a .token, which there's our big token. And it has a .user with our username, password, and ID with isadmin set to false.
What's that _b?
That is something MongoDB gives it for version. So if you're upgrading your API, your database, you can change the version numbers, things like that. It's given to you just like the ID is. I've never used it though. I have not. And notice we got our little logger here saying a 201 request. So we send in the rec.body.username. Let's make sure this works now. If I try to send a post request with the same username, what should I get as my response from what we have in this route? Yeah, we should see this. So I'll try to post again with the same data to see, does it break? Awesome. My authentication works. And this is the response.data of a catch. So I could save this in state and show it on my sign up form. And then they'd see this message when they made a whoopsie. Well, we're missing one more route. Yeah, we're not going to cover that, but for the context of this, we're just going to make sure that they remember their password. Okay, what is the other route we're missing? What other functionality do they need? We've allowed them to sign up. We got to log in. Auth router dot. Would this be a post, put, getter, or delete? Post. Well, I'm not posting something new. It's still post because we're sending an object. So it'll be to login. Now let's follow the train of logic of the login. They're going to send us a username and password. And what is the first thing we're going to want to do? Yeah, we'll see if what matches. So how do we know if the password matches if we don't know the user requesting it? Yeah, so just like the sign up, we're first going to go query the database to say, hey, does a user by this username exist? If so, then we'll check the password. So we'll start it off the same way. We'll ask user.findOne, find one with the username being requested by the user. But what if they signed up with all caps Harry, and then they tried to log in with all caps Harry? It's going to break because it's saved lowercase. So regardless of how they sent us their username for login, we're going to lowercase it when we go look for them in the database, just to make sure that if they typed it with the wrong casing, since we're saving all users as lowercase usernames, we got to query it by lowercase. So you're saying if I didn't have this, then it's a lot harder to find that user, because what if the first time they typed the username it was with caps and the second time it wasn't? It would say that. Oh yeah, for like saving or querying it. Yeah, we could do that. We'd have to do that before we save it. So if we do it here, it's going to do it for us. If we don't do it here, we'd have to manually turn it to lowercase here before we run this line. We'd have to say rec.body.username.to lowercase and reassign the rec.body.username to that. So we're going to have to do it manually or just let the schema do it for us. So it's better if the schema does it for us. All right, well, first we handle our error after we try to see if the user exists. But now, what things do we need to check for? We need to see, first, does a user by that username exist? And does their password match? Now, for now, we're going to handle this all in one if statement. Later, we're going to break it into two parts, but we want to ask both these questions at once. We're going to ask if this query came back and there was not a user, or maybe the user did come back. So if the user.password does not match the rec.body.password. So this is going to handle both cases. If the user doesn't exist, then we need to throw an error. And if they do exist, but their password doesn't match the one that was just submitted, that should also cause an error. So we will set the status to something unauthorized, like 403. And we'll have to send our own custom error. What would be a good error message if either their username or password are incorrect? Yes. The username or password are incorrect. Now, it wouldn't be good to say username is incorrect or password is incorrect, because then we're letting them know where they messed up. And if it's malicious, we don't want to give them any hints, so it's best to keep it general. Either of them or both are incorrect. You figure it out. Thank you. That was a very bad error that would have messed up many things. So that right now this is handling both. We're going to break this into two different if statements in part 3, but this will be just fine for our purposes right now. Well, if they make it to line 51, that means they exist and their password matches. That is authenticated. So what do we do once they're authenticated? We create the token, we send the response. So const token is jot.sign. We need to send the user object as an object for the payload. So user.toObject. And then we need to add our secret. And how do I access my secret? Process.env.secret. My token is created. I can then safely return res.status of 200 would be a successful get. This is an authorized. We are having so many good numbers shouted out right now. Let's see which one it is. Yeah, 401 is unauthorized, 403 is forbidden. I think we'll just stick with 200. Successful request. Yeah. 200.send. We're going to send an object that has our token and our user in it. Now, I didn't have to say user : saved user because of object literals. It's going to see this variable and create the key value pair for me. But saying this on both keys would be the same as not saying it. I can either give it the key value or I can just give it the two values and it will generate the object for me. All right, we can test this route. That is our login. So let's log in as our existing user, AA. Let's send. There we go. It just created a new token and send us back our user object. So we could, on their front end, we could say, you know, in the profile, welcome at user.username and customize it to them. Now let's try to log in with some bad credentials. That password does not match. So what should we see as the error message? Right, it's not going to make it past here. We'll send. Great. I promise you the first time you do this, it won't be this simple, and I apologize for that. You will do maybe you will get it the first try. It's pretty hard because there's a lot going on here. But I would test all eventualities. Do a successful sign up, do a failed sign up. Do a successful login, do a failed login. And that creates our sign up and login capabilities. Now we have 15 minutes. If you're good to keep going, we'll introduce the to-dos, create a to-do for the user, and end it there for now. But as you can see, it does add quite a bit of code. Both of these routes and your whole user model is really all that we've added so far. But how many new node modules have we installed? .env and JSON Web Token. Great. So as we see in Postman, when we successfully do something, we get the token and we're going to save this in state and in local storage on the front end. They need it while they're logged in. Because whenever they send a request, we're going to write a request now to add a to-do. That is something we're only going to let them do once they're logged in so we can save it as theirs. They're going to have to send this token back to us on that request. What is inside of the payload of this token? What did we put inside of that jot sign when we created the token as the first argument? It's the user. So it has their username, it has their password, it has their ID. So really, every time they're sending a request, they're sending us all their information as well. They're sending us in the form of a token, but we're getting all their info. When they log in, it'll generate a new token every time. Yeah. Because when they log out, we're going to delete the token. So if they want to log in again, they have to redo the process and get a new token to come in. So what we need is a gatekeeper. We need someone that checks for a token whenever the request requires a token. So next node module to install. The third node module of the day. We will npm install something called express-jot. An express jot is just like express JSON. What does express JSON look for? Rec.body. Well, it looks for an object and turns it into rec.body. What express jot does is it looks for a token, and if it exists, it decrypts the payload and creates a rec.user. So we'll have a rec.user._ID of the requesting user on every request, which is very nice. We don't have to worry about sending the ID. Express is doing that for us. So we want our gatekeeper at the top of these routes. We're going to require an express jot so we can use it. Just like so. And then we're going to tell our server to use express jot whenever the request needs authentication. So we'll say app.use, and then we want to set up an endpoint that all authorized requests have to go through. And a good convention for this is /API. So any request that starts with /API, use express jot and try to see if it has the secret that matches our local secret. This is the gatekeeper. Checks for a token on requests to /API. If there is a token, it will create the rec.user object. If there is not a token, it will throw an unauthorized error. So it's going to stop the request right there if they don't have a token. Well, because this is a new kind of error coming down, we need to adjust our global error handler to be able to catch this error that it might throw. So we're going to check if the error's name is an unauthorized error. Let's make sure all the information gets back by setting the status to that error status. And we have to do that here because there's no chance here to handle the error. It's being forwarded right to our error handler. So we're just going to check every time an error comes in, was it an unauthorized error? That's a very specific one thrown by ExpressJot. If so, make sure they get the right status, which is usually 403, and then just send it as normal. That's quite a bit to add there, but this is what really battens down the hatches, so to speak. All right, so now we're going to set up the routes for the to-dos, but these are secure routes. You should only be able to do this if you're logged in. So what would the endpoint be to make a post request to to-dos? /API /to-do, or whatever you choose to call this. But because whatever this is handling, whatever this router is going to be handling requires authentication, we're going to start the endpoint with API. So to get here, it first has to go through this and make sure the token was present. We'll require in our routes the to-do router, which we haven't created yet. I'm actually going to put this on a separate line just so it's easier to see. All right, so you got to go through this to get through anything authorized. So this is wonderful because, again, this creates the rec.user object. So inside of this route, we'll have a rec.user that has the ID of the person requesting it, so we can easily go and grab their to-dos. So we're going to make a to-do router and pull in all the required things. And we'll pull in our to-do model. Require models are to-do. So we're just going to do get all by user and add new to-do. And that'll be good. So first, the get all that belongs to a specific user. To-do router.get. We'll just do it to / with rec res and next per normal. And we want to query our to-do database to find all to-dos that have a .user equal to the requesting user. So if we go back to our to-do model, remember each one will have a .user when it's created. It'll have the ID of the user that created it. So in our querying, we're going to say find all to-dos whose .user is equal to the requesting user's ID. And we have that because of express drop. We have the ID of the person requesting. Standard error handling, no different. But if it makes it to here, we can return res.status 200 and send the to-dos. These belong, this is the array of to-dos that only belong to this specific user. I know it's so much stuff, and this is part one. I think it's good that we're covering this early so we can review it again and again and again. Add new to-do. We need to make sure that when we do a find, this is set up on each to-do. So how do we add the user's ID to the to-do? We won't be sending this in the post request. So to-do router.post /. We need to add the user's ID to the to-do. So rec.body right now will just have a .title. I need to add to it a .user and set it equal to the user's ID. Now, how do I have access to the user's ID? rec.user._ID. I only have this because they are already logged in, and this data came in with their token. I have access to it. So now I've added their relationship. Now the rest of it's a regular post request. So we'll say add user's ID to the new to-do object before saving it in the database. Now we can make our new to-do with our to-do model, the rec.body, and save it. Provided it makes it this far, it means it was saved successfully, so we'll return a res.status of a 201 and send the saved to-do. And now we get to test it and then go to lunch. How do you test something this complex? Practice. Let's go to Postman. Actually, we need to make sure our routes are set up. We do. We say any request to API to do requires a token. So let's just try to post a to do without a token and see what happens. We're going to set a request to API to do a post request with just the title, all it's expecting. My first to do. But I haven't worried about tokens or anything. I'm just sending it. I send it. And no token was found. It didn't make it past my gatekeeper. It didn't find a token. So what I really need to do is first log in. So I'll go to login and I'll submit the username that we have, A, and the password, A, and I'll log in. And now I need to add the token for my next request. So I'm going to copy this token. I'm going to open up a new Postman window here for this next request. Localhost 7000 /API/to-do and do a post. The headers you'll always need. There's one that should be there by default. Content type is application JSON. But now we need to add an authorization header, and this is what ExpressJot checks for. So we add the token as an authorization header, and the value needs to be the word bearer, capital B, space, and then the token. This is how we add it to the outgoing Axios request, so that the ExpressJot gatekeeper will be able to see this, decode it, and let us through. the body, I'll send some raw JSON. My first to do. And I'll send and just hope for the best. Great. There's my new to-do object. My first to-do, it has its own ID, but it has a .user equal to the user's ID that I logged in with. See, this is the same ID as the user that sent the request. So they are now related. So I'm going to post a second to-do and a third to-do. Now this user has 3 to-dos registered to their ID. Because now I would like to do my GET request and say find all to-dos whose .user equals the ID of the requesting user. So I should get an array back of those 3 to-dos belonging to this user. And there we go. They all have the same user relationship. If you find that easy, then awesome. It's not. And in fact, to be completely fair with it, when you get to a company, the chances of you dealing with authentication is slim because that's its own little career. It's called web security. And you get to learn a whole different stack called TCP/IP, and there's all these ins and outs of it. But if you're in a startup and you're the developer of one, you're going to want to know how to build an authentication system. So at least know how they work, because tokens are in pretty much every authentication system, and they're always attached some way or another, typically through headers or parameters. Express, JOT, and JSON web tokens are through headers. That's how we're sending it. That is now done.